Good afternoon, everyone. So today we are going to have a practice calculating concerns or word problems regarding about energy, work, and power. Okay, just I want you to prepare your notebooks if you have, so that we have some reference, especially for the formula that we are going to use. Okay, so I also provided here or prepared something here, especially calculator. I want you to prepare that. But I have a calculator also here so that we can calculate it together. Okay, or I mean, I can show you how to calculate it properly. Okay, so most of the questions here are also the same questions that we've had last meeting, especially for the activity number 4, if I'm not mistaken. Okay, so let's try. Okay, for this one. Okay, so a cat has a mass of 4 kilograms, climbs up a tree at a height of 5 meters. Calculate the gravitational potential energy of the cat. So it is very easy. A good example or a good way in order for us to make sure that we know what to calculate is, of course, knowing what is the variable we are trying to calculate. So in this situation, we ask calculate the gravitational potential energy. So GPE, okay? I apologize because I forgot to bring my pen or my tab. So I am using my what is this? My mouse to write words and numbers. So but it will work. Okay? So GPE can be calculated by mgh. M is mass, G is gravity, H is height. Okay. To make sure, let's see if the variables on the situation are all present. Is there mass available? In order for us to make sure it's a mass, it's in kilograms. Yes, there is it, the mass. And then how about the gravity? Although gravity is not present here, we must know and understand that gravity, although it's not present, gravity is always given. It's constant, 9.8 meters per second squared. Okay, and then for the height is in meters. So here, 5 meters. Remember, when we do calculate a variable, make sure that all the given must be in SI unit. So in this situation, for mass, it must be in kilograms. And then for the height, it must be in meters. So if everything is present, let's make it into our solution, or we convert the variables into our formula. So mass is 4. Okay, let's multiply it with gravity. Gravity is 9.8 meters per second squared. And then we have 5 meters for the height. So it's like this. So if you're going to use your calculator, what would be the result? So 4 times 9.8 times 5. I have here my calculator. I'm going to share it to you. Okay. So that would be 4 times 9.8 times 5 meters. So our answer will be wait, what happened? Okay, that's it. Our answer is 196. So 196 is our variable or our answer. 196. We are looking for gravitational potential energy. So it will be 196 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . 96 . joules. So that is your final answer. Okay, next. Okay, I'm going to erase this first. Okay, let's proceed to the next example. Next example is a football player or a football has a mass of 0.4 kilograms and it was kicked. It was kicked with a velocity of 5 meters per seconds. So uh, calculate the kinetic energy. So in this situation, we calculate the kinetic energy. Okay, if you can still remember, kinetic energy can be calculated by how, or how can we calculate by kinetic energy? Kinetic energy can be calculated by 1/2 mv squared, or mv squared divided by 2. Whether you're going to use this first one or this second one, the result will be the same. Okay, now let's check if the variables needed are all present. Is mass available? Mass must be in kilograms. Yes, it's given. How about velocity? Yes. So everything was given, so meaning we can proceed. Let's substitute the given into the formula. So it's going to be 1/2. Mass is equivalent to 0.4. 0.4 multiplied by 15. Okay, this is a crucial one. Okay, this is a crucial one. The squared. Okay, that is the crucial one. That is very important because most of the time, some of us forgot to put the square symbol here. So sometimes if we forgot to put the square root symbol, it changes everything. Maybe we overlook that it's missing there. So our calculation will be wrong. Okay. First step, if everything was already converted or everything already substitute, this is the first thing we are going to do. We square the velocity. So if we square the velocity, that would be 15 times 15. What is 15 times 15? Okay, 15 times 15 multiplied by 0.4. And then multiplied by 1/2. So 1/2 can be interpreted by multiplied by 0.5 or divided by 2. Okay, in this time, I'm going to use 1/2 as 0.5. So we're going to make it another multiplication and then 0.5. And then your answer goes, what's your answer? Okay, so that would be 15 multiplied by 15, that is 15 squared, multiplied by 0.4. Okay, maybe you can put equal sign, or if you want, you can multiply it by 0.4 or divided by 2. You're going to have the same answer. So 90 divided by 2, that would be 45. Okay, so your answer will be 45. The unit is joules. Clear? Next one. I'm going to erase this. Okay, let's proceed to the next one. Okay, these are, this is a two-part question. Okay, so an object with a mass of 2 kilograms is held at a height of 8 meters above the ground. Calculate the potential energy. That's for the letter A. And if the object dropped, state its kinetic energy. Okay, look at this. This is very tricky, but an easy one. when we calculate something, especially when we do calculation and problem solving, we also, or one of the best example that we can do is at least draw. If we cannot imagine, at least draw. Okay? So for example, in this situation, okay, an object is on the height of, for example, let's use an object ball. Okay? A ball is around 8 meters. Okay? So it is 8 meters above the ground. So the ball is 2 kilograms. Now, in this situation, the ball is just held on a certain height. So meaning the ball is still here, not yet released. So if we're going to talk about what is the GPE, GPE is very easy with this one. Okay? Because GPE is equivalent to mass, gravity, multiplied by the height. Let's check if the variables needed are all present. Is there mass available? Yes, 2 kilograms. Is there gravity? Yes. Although it's not stated, it's still given, 9.8 meters per second. Is there height available? Yes. So if everything is given, we can calculate for GPE, gravitational potential energy, wherein mass is 2 kilograms. Gravity is 9.8. And then for the height is 8 meters. Using your calculator, the operation is only multiplication. Okay, you can do it by yourself. So 2 multiplied by 9.8 multiplied by 8. And then click equal sign. You are going to get 156.8 joules. 156.8 joules. Now, for letter B, if the object was dropped, okay? So the idea is, if the object was dropped in this height, you already know that you have 156.8 joules PE. According to the law, energy can be transferred. Okay, we cannot do anything to energy. We cannot create it. We cannot destroy it. We can only convert it into another form. So in this situation, PE will be converted into KE. How can you do that? I'm going to proceed to the next slide. Okay, so I'm going to erase. Okay, assuming that KE is equivalent to 1/2 mv squared. Same scenario. Let's check if the given is, or if the needed variables are present. Is there mass? Yes. Is there velocity? No. If you're going to make an argument, sir, we can create a formula of velocity using cancel method. Let's try. This and this. Let's cancel out. Okay, we are creating velocity formula here. So now we are going to cancel out 1/2. I put 1/2 here. I put 1/2 on the other side. Okay, of course, this will be canceled. This will be canceled. I want to cancel out mass. We put mass here, cancel, cancel. We put mass also here. Now, we are going to cancel out square. So we put square root here. And we put square root, we put square root here. Making this cancel, this square cancel. So we will be having a formula. Velocity is equivalent to square root of KE divided by 1/2 mass. Okay, KE is equivalent to 1/2 mass. Is there KE available? No. But if you're going to apply the law of conservation of energy, if all energy was converted, all PE is converted, PE and KE will be the same value. So meaning your value for KE is 156.8. Now, if we are going to use this formula, it is going to be long. Okay, it will take us longer. But what's the shortcut? If you know that PE is equivalent to KE, we also agree that PE is equivalent to mgh, and then KE can be also calculated by mgh if all the potential energy held by the object was all transferred. In this situation, if the object dropped from that height, all the potential energy that we've calculated earlier will also change into another form, but the value will be the same. So KE can be calculated by mgh, wherein mass is 2, gravity is 9.8, and then height is 8. And then you are going get, or you will be getting the same value, 156.8, sorry, 0.8 joules. It will be the same. Next, now, a runner has a mass of 60 kilogram, or a runner of mass has a 60 kilogram, or which is a 60 kilogram, has 750 joules of kinetic energy. Calculate the velocity of the runner. Okay, this time we are going to make our own formula. In this situation, kinetic energy is mentioned, and kinetic energy we are going to calculate for velocity. So meaning we are going to make our own formula. We are going to make velocity formula out of kinetic energy formula. Okay, so remember, kinetic energy is equivalent to 1/2 mv squared. If you're going to recall, how can we make our own formula? First step, we write the formula. We write the original formula stated. Okay, in this context, kinetic energy. We only have two primary formula, kinetic and potential. In this situation, kinetic. First step, write the formula. Second step, we are going to cancel out. Okay, since velocity is in this side, we are going to focus on our right side. Okay, now we want to cancel out 1/2. We cancel out mass. We want to cancel out square. How can we do that? Divided by the same value. Remember, when you put value here, you must put also a value on the other side, making this cancel, cancel. Okay, we cancel mass, we put here, we put mass here. Cancel mass, cancel mass. On this side, we cannot cancel everything or anything because you can only cancel if there are two similar values. If there's no similar values, we cannot cancel out. Now, this is the last problem. You cannot cancel out with square. You cannot directly. But we can cancel that using square root. But of course, when we put square root here, we put square root here also. So square root here, cancel. Square will be cancelled. Everything on the left side will remain. Okay? So everything is cancelled out except velocity. So we have velocity is equivalent to, Velocity is equivalent to square root of KE divided by 1/2 mass. Now, let's check if the needed variables are present. Is there KE available? Yes, according to the situation, KE is 750. Is there mass available? Yes, according to the situation, mass is 60 kilogram. Next step, substitute. Velocity is equivalent to square root of KE. KE is 750 divided by 1/2 of 60. In this situation, we are going to use 30 here. So instead of 1/2 60, we are going to divide 60 immediately. Okay? So we are going to put 30 here. How did we get 30? 60 or 1/2 of 60 is 30. Okay. Let's do it using our calculator. Let's do 750 first. 750 divided by 30. 750 divided by 30, that is 25. Now, what is the square root of 25? The square root of 25 is equivalent to 5. We are looking for velocity. What is the unit for velocity? Meters per second. So the final answer will be 5 meters per second. Okay? Next. Clear? Let's go here. A book on a height of or high shelf has 80 joules of gravitational potential energy. If the mass of the book is 1.6 kilograms, calculate the height. Now, we are going to, or in this situation, we are going to make our own formula first. Now, what primary formula we are going to use? In this situation, we are using gravitational potential energy. So GPE, write the formula. GPE is equivalent to mgh. That is the first step. Okay? Now, we are looking for the formula for height. So meaning we are going to cancel out everything except height. So first step, write the formula, gravitational formula. We divided both sides. Now, we want to cancel mass. How can we do that? Put mass here. Of course, we put mass on the other side. This one cancel, this one cancel. We want to cancel out gravity. Okay, we put gravity here, we put gravity there. Gravity here will be canceled. Gravity here will be canceled. Everything what was canceled but height. So if we're going to read it backwards, height is equivalent to GPE divided by mass gravity. Now, let's check if the variable needed are all present. Is there GPE available? Yes. According to here, 80 joules of gravitational potential energy. GPE, check. Is there mass available? This is mass, 1.6 kilograms. Mass, check. Gravity. So gravity is 9.8, so everything is present. Let's substitute. So height is equivalent to GPE, 80, divided by, what is mass? Oh, sorry. The mass is 1.6. 1.6 multiplied by 9.8. Since we have something like this, okay, we multiply 9.8 to 1.6 first. So 1.6 multiplied by 9.8. You will be getting 15.68. So 15.68. Okay. So it is going to be 80 divided by 15.68. So let's do it. 80 divided by 15.68. You will be getting, so there's a lot of variables. So 5.102. Okay, so I'm going to erase some of this. Okay, I'm going to erase some so we can write something. Okay, I erase this one. Erase, erase. So we end up like this. So 80 divided by 15.68. So if we're going to use our calculator and we do this, you will be getting 5.10.20.40816, which is very long. Now, what is our final answer? We remember, okay, this is very important. This is a universal standard. Locate the decimal point, that is the decimal point, and our final or we are going to get 3. Okay, only 3. Why? We are going to round off. Okay, round off to the nearest thousandths. Okay, we are going to put the spotlight on the third one. If the third number, okay, is 4 below, meaning the number on its left will be staying. If the number is 5 above, the number or the number on the left side of that third number will be adding 1. So maybe increasing 1, round up. Okay, so in this situation, this is 0. So this is 4 below. So we are going to have our final answer, 5.10. We are looking for height, so it is in meters. So this is our final answer. Okay, so erase. Next. Okay, so this is also a two-part question. A diver has a mass of 50 kilogram, jumps off a diving board at 10 meters above the pool. First, letter A, calculate the GPE. This is the same situation as earlier. So in this situation, the diver is still on the top. Okay? The diver still on the top. That is letter A. For the letter A, we are looking for GPE. How can we calculate GPE? This is easy. GPE is equivalent to mgh. Is mass available? Yes. If gravity available? Yes. Is height available? Yes. Everything is available. Just substitute. Mass is 50 multiplied by 9.8 multiplied by 10. If we're going to calculate that, okay, using your calculator, calculate 50 multiplied by 9.8 multiplied by 10. You will be getting 4,900. 4,900 joules. Now, look at the situation B. Assuming no air resistance, calculate her speed just before she enters the water. Now, we're going to recall something. If you are going to drop or you are going to jump, when you already hit the surface, for example, you are going to convert all the kinetic energy into PE. So meaning you are going to be stationary again. So if you're going to consume all the kinetic energy, where is the highest or the maximum kinetic energy? That is before you land on the surface again. So meaning, assuming that everything was converted, okay, calculate the velocity. So in this situation, the term used is speed, but the direction or the object will be moving in a straight line downwards. So speed and velocity will be the same value. Okay, if you recall your grade 7 physics, if an object move in a straight line, speed and velocity will be the same. Okay? Now, since you know your PE and you know that the object moved in a downward motion, converting all PE into KE, so meaning your KE is also 4,900 joules. 4,900 joules. Now, how can we, or what is the formula of KE, or sorry, velocity using the KE formula? It's very easy. So, KE is equivalent to 1/2 mv squared. Calculate or make our own formula. We need velocity to stay. So 1/2 m 1/2 m. Cancel this because they are the same. Cancel this because they are the same. How to cancel square here? We put square root. And then we put square root also on the other side. So cancel the square root on the right, cancel the square on the right. Making velocity is equivalent to, sorry, I'm going to erase that. I'm going to move a little bit up. Okay, so velocity is equivalent to square root of KE divided by 1/2 mass. Okay, let's see if the variables needed are all present. You have KE? Yes, this is your KE. Because your PE and your KE is the same if all PE is converted into KE. They are the same. Do you have mass? Yes, mass is given here. Okay, so everything is present, just substitute. So we have square root of, what is your KE? 4,900 divided by 1/2 mass. If your mass is 50, what is the half of 50? That would be 25. Now, using your calculator, what is 4,900 divided by 25? 4,900 divided by 25, that is 196. So, what is the square root of 196? Square root of 196. The square root of 196 is 14. You are looking for velocity, so the unit will be meters per seconds. Meters per seconds. Okay? Clear? Next. Okay, a roller coaster car has a mass of 300 kilograms, starts from rest at the top of a hill with 20-meter high. Okay, this is a tricky one. Okay, so calculate the mechanical energy of the car at the top. Okay, I saw some papers that has two different approach, but I also accept their answer correctly. Okay, so remember, mechanical energy or total mechanical energy can be calculated by PE plus KE. So meaning, before you get your total mechanical energy or TME, you need to calculate separately PE and KE. Now, So we go to GPE first. How can we calculate GPE? MGH. Let's make sure if the variables of needed are all present. Do you have mass? Yes. Do you have gravity? Yes. Do you have height? Yes, 20 meters. So everything is present. So let's put 300 multiplied by gravity multiplied by 20. So you're going to get GPE. So using your calculator, let's make 300 multiplied by 9.8 multiplied by 20. You will be getting 58,800 joules. Look at this. These three words will change the idea. Calculate the total mechanical energy of the car at the top. So meaning, the car will not move. The roller coaster will not move. Making your KE 0 joules. Making your KE 0 joules. Some students assume that all the kinetic and potential energy will be converted. So they make it times 2. It's fine. Okay? They assume it's okay. But if you see this word, you have a keen observation. The question on letter A, the car is still on the top. Making kinetic energy is 0. So the final answer is this, or times 2. Your answer are both correct. Now, let's go to letter B. Letter B is very tricky. Look at this. Calculate the speed of the car when it reaches the lower point of the track 5 meters before the ground. 5 meters before the ground. So making, for example, I'm going to make it a straight line. So from here, going here, that is 20 meters. So the roller coaster moved from the top 5 meters before. So we are going to calculate again the PE using 15 meters. Okay? Because it doesn't says that the cart or the roller coaster reached the lower ground or the lowest ground. It says before 5 meters above the ground. So that is 15 meters. So making your 20, calculating GPE again, using 20 only for letter B. So it is going to be like this. So GPE again. So GPE is equivalent to, you have 300, that is your mass, multiplied by 9.8, that is your gravity, and then 15 for your height. Because the object did not reach the 0 meters. It says 5 meters above. 5 meters before or high. So making it 15. So if we're going to look our using our calculator, we're going to do it again. 300 multiplied by 9.8. Now multiplied by 15 only, not 20. Making it tricky but not difficult. Okay? So we have 44,100 joules. 44,100 joules. Now, since you already calculated the PE and then the situation the PE is converted. Now, so this is also your KE. Now, we are going to calculate for the speed. How can we do that? Okay, velocity is equivalent to square root of KE divided by 1/2 mass. Is KE available? Yes. They are equal. Do you have mass? Yes, 300. Let's substitute. So KE is 44,100 divided by, sorry, that's 100. 44,100 divided by, what is the 1/2 of 300? That will be 150. Okay, so we're going to do it again. 44,100 divided by 150. You're going to get square root of 294. So what is the square root of 294? Square root of 294 is 17.15. 17.15. What is the unit? Meters per seconds. So 17.15 meters per seconds. Okay, let's proceed. Okay, an archer pulls back a bowstring storing 120 joules of an elastic energy. When it is released, all this energy is transferred to an arrow of 60 grams. Calculate the speed at which the arrow leaves the bow. Now, this is not difficult again, so we draw that bow. Okay, I hope the bow I'm trying to draw is correct. Okay, something like that. So it looks a bow. Okay, now, when the bow is stretched backward, you are storing energy. So the PE, stored energy, your potential energy is equivalent to 120 joules. So meaning, when you store 120 joules of energy, when you released it, all 120 joules will be converted into KE, the same value. Okay? If the mass of the bows is 60 grams, what is the speed? Look at this. Arrow will be moving a straight line or in a straight line. So meaning, speed and velocity will be the same. But there is a concern here. Look at this. Grams. Grams is not an SI unit. Grams is not SI unit. So meaning you need to convert grams first. How can you do that? Divide it by 1,000. So 60 divided by 1,000, that would be 60 divided by 1,000. You are going to use you're going to use 0.06 kilograms. Okay? So 0.06 kilograms. Remember, before you calculate, make sure that all values are in SI unit. Now, the variable we are looking for is speed or velocity. Okay? So velocity can be calculated by square root of KE divided by 1/2 mass. Now, let's make sure if everything is present. Do you have KE? Yes. They are the same. Do you have mass? Yes. So everything is present, just substitute. Square root of KE is 120 divided by 1/2 of 0.06. Now, if we want to shortcut, we divided 0.06 divided by 2. So 0.06, let's divide it by 2. You are going to get 0.03. So instead of 1/2 0.06, let's change it into 0.03. How did we get 0.03? 1/2 mass. If your mass is 0.06, what is the half of 0.06? 0.03. Okay? So you will be having square root of 120 divided by 0.03. You are going to get square root of 4,000. Square root of 4,000. That would be 120 divided by 0.03. 120 divided by 0.03 is 4,000. Now, what is the square root of 4,000? The square root of 4,000 is 63.25. What is the unit? We are looking for velocity. So meters per seconds. Meters per seconds. Let's proceed. Next. Okay, a pendulum bob has a mass of 200 grams, is pulled aside so that it rises by a vertical height of 15 centimeters. Okay, calculate the maximum gravitational potential energy. Calculate the gravitational potential energy. Okay, look at this. So if, as you know, what is a pendulum is? A pendulum is something like this. It sways back and forth. Okay, it sways back and forth. It is something that you can find on an old clock. Okay, that is a pendulum. Okay, so the pendulum has or is 200 grams, and then it is going to be pulled aside. So making it like this. Let's say this is the ground or this is the zero height. Now, the pendulum was pulled to the other side. So like this. Okay, let's see. It is pulled on this way, making the height of the pendulum from the 0 degrees is 15 centimeters high. That is the situation. Now, it's very easy. We are looking for GPE. How can we calculate GPE? So GPE can be calculated by mass, gravity, and height. Everything is ready. It's just that there's a little challenge that we need to make sure that we always do. Look at this. This is grams. This is centimeters. Do you see something different? Yes, they are not in SI unit. So in order for us to make kilograms from grams, so 200 divided by 1,000, you are going to get 0.2 kilo. That is your mass. For centimeter to meter, 15 divided by 100. So 15 divided by 100, that is 0.15. 0.15 meters. So everything is prepared. They have mass? Yes. They have gravity? Yes. Do you have height? Yes. Everything is prepared, just substitute. Mass is 0.2. Sorry, 0.2 multiplied by the gravity, 9.8 multiplied by the height, this is 0.15. 0.15. Okay, let's use our calculator. 0.2 multiplied by 9.8 multiplied by 0.15. What will be your answer? Your answer will be 0.294 or 0.29. What is the unit? Joules. 0.29 joules. Okay, next, clear? Okay, let's proceed to work. A worker is tasked to push a 150 kilogram crate on a 10-meter ramp with an angle of 30 degrees. How much work must he do to accomplish the task? So, I'm going to draw, okay? For example, this is the ground. Okay, this is the ramp. Okay, the ramp is around 30 degrees. That is the ramp. And then the man is pushing a crate on the ramp. Okay. And then, of course, it moved. So meaning the amount of force that he used, the worker used, is greater than the mass of the crate, making it move or making the crate move. Okay. So if you're going to recall the formula of work with an angled situation, it is going to be force displacement multiplied by cosine theta. That's it. Now, let's see if the given are all present. Do you have angle? Yes, there's an angle here, 30 degrees. Do you have displacement? Yes, 10 meters. Do you have force? No. But is there a possible way to get force? Yes. Force is equivalent to mass multiplied by the gravity. Now, to correct the formula, we are going to use force is equivalent to mass, gravity, displacement, cosine theta. Now, let's make sure that everything is prepared. Do you have mass? Yes. Do you have gravity? Yes. Do you have displacement? Yes. Do you have angle? Yes. So everything is prepared. Okay, everything is prepared. Now, we are going to maximize the power of our calculator. Okay, so if everything is present, we are going to put it in the calculator as 1. Okay, so what is mass? 150. What is gravity? 9.8. What is displacement? 10. And then what is the angle? Cosine 30. Okay. Let's maximize the power of our calculator. Okay, let's do it together. Open parenthesis, 150. Close parenthesis. Open parenthesis again, 9.8. Close parenthesis. Open parenthesis again, 10. Close parenthesis. Open parenthesis, click cos. And then put 30. Close parenthesis. And then equal sign. you are going to get 12,730.57. 57 joules. How did we do that? Okay, you can also do the shortcut version. Okay, shortcut version, clear. Okay, let's put cosine 30 equal sign. Cosine 30, you should get 0.860254038. You have the answer. Okay, let's multiply 10. Multiplied it by 9.8. Multiplied it by 150. You should get the same value. Work is equivalent to 12,730.57 joules. Okay, next. A student pushes a desk with a force of 20 newtons across a floor with a distance of 5 meters. How much work did the student do on the desk? Okay. The student is trying to push a desk. Okay, something like that. Okay. And then he managed, or the student managed to move the table, making have an idea that the force he used is greater than the mass of the object. Okay, because it moved 5 meters. Okay. The movement is horizontal. How can we calculate that? Force multiplied by displacement. Okay, let's check if the variables are present. Do you have force? Yes. Force, the unit is Newton, so 20 newtons. Do you have displacement? Yes, 5 meters. So everything was set. Just substitute. Work is equivalent to force is 20. Multiplied by displacement is 5. What is 20 multiplied by 5? That would be work is equivalent to 100 joules. Okay, 100 joules. Next. Okay, a worker pushed a box on a 45-degree ramp using 500 newtons of force, making the box move 10 meters. How much work did the worker created on this situation? How much work did the worker created on this situation? Okay, so this is an example also of calculation of work using cosine. Okay, so we don't have any formula calculating work using, or if angle is available, but work is equivalent to force, displacement, cosine, angle. Okay, let's check if the given are all, or the variables needed are all present. Do you have force? Yes, this is your force. Do you have displacement? Yes, this is displacement. Do you have angle? Yes. So meaning everything is present. What do we need to do is just substitute. Force is 500 multiplied by displacement, which is 10, multiplied by cosine angle of 45. Okay, let's maximize the power of our calculator. Let's do it together. Open parenthesis, 500 close parenthesis, open parenthesis, 10, close parenthesis, open parenthesis, cosine 45, close parenthesis, click equal sign. Did you get it? Okay, wait. Something wrong. Okay. So you will be getting 3,535 point. So 3,535.53 joules. Okay. Let's do it in a different manner. Let's do cosine 45. Cosine 45 must be 0.7071067.812. That is cosine 45. It's going to be like this. Okay, cosine 706 something something. And then let's multiply it by 10. And then multiply again by 500. You are going to get the same value. Okay, next. Okay, a crane lift a 10-kilogram box at a height of 2 meters. Calculate the work done by the person in lifting the box. Okay, work. Okay, so the lift, so I cannot draw, but I'm going to replace the drawing with an actual lift, an elevator. Okay, elevator like that. Okay, this is the zero ground. And then since there's a lift, meaning it moved above the ground. Okay, so the box is 10 kilograms and then the height is 2 meters above the ground. How can you calculate the work done? Okay, now the situation is vertical now. So if the situation is vertical, we can use mass, gravity, displacement. Actually, it is the same with F and D. It's just that if the F or the force is not available, but the mass is available, you can get force by multiplying mass to gravity. Okay? So we are going to use this one. Now, let's make sure that everything is available before we calculate. Do you have mass? Yes. Do you have gravity? Yes, constant. Do you have displacement? Yes. Okay, let's substitute. Work is equivalent to mass. That would be 10. Multiplied by gravity, that would be 9.8. And displacement is 2. Okay, using your calculator, let's calculate 10 multiplied by 9.8 multiplied by 2. You're going to get 219.6 unit for work, joules. Okay, next. Okay, a motor lift a 50-kilogram object to a height of 10 meters in 5 seconds. Calculate the power. Okay, the power now, okay, or power can be calculated by work divided by the time. We can also calculate it using, or we can also use triangle for that. Power is work divided by time. I'm sorry. This is supposed to be letter T, not S, like that. Okay, in this situation, um, we are calculating for power output. How much power do we have? Okay, now, this is the formula of power. There's no other formula for power instead of, aside from this. But look at this. This is work. Is there work available in the situation? No, because there are some situation like this that we need to calculate for work first before we calculate the power. Now, so instead of using this one, we are going to expand it using a formula for work. Okay, in this situation, it is vertical, or the movement is vertical. So we can use the vertical unit or formula of work using mgd divided by time. Don't be confused. Mgd is the same as work. Okay, this is the formula of work earlier. It's just that we don't have work. So we need to calculate work first. Mgd is the formula for work. Now, let's substitute. In order for us to calculate power, do you have mass? Yes. Do you have gravity? Yes, constant. Do you have displacement? Yes, 10 meters. Do you have time? 5 seconds. Yes, everything is present. Let's substitute. So we have 50 multiplied by gravity, 9.8, multiplied by 10, displacement, divided by 5. Okay, if you cannot continue, or if you cannot do it, what is this? If you cannot use your calculator or maximize your calculator, it's okay if you calculate first something on the top. So that would be 50 multiplied by 9.8 multiplied by 10. So you are going to get 4,900 divided by 5. Or if you want, you can continuously doing that, but it's okay. Let's divide it by 5. You are going to get power is equivalent to 980. What is the unit of power again? So this is joules, this is seconds. We cannot cancel them out, so we bring it together. Joules per seconds. That is your final answer. Okay, last one. This is the last one. An elevator motor does 600 joules of work to lift an elevator. If the motor takes 30 seconds to do this, what is the power output? What is the power output? So we are going to calculate power again. Power is equivalent to work divided by the time. Okay, this is the usual thing we do. This is not the last time. This is not the first time we do it, and also this is not the last time. We make sure that everything is available. How to check? Do you have work available? Okay, according to this, 60 joules of work. Work is present. Do you have time? 30 seconds. So everything is present. Just substitute. Power is equivalent to work. 60,000 divided by 30. Okay, using your calculator, 60,000 divided by 30, that would be power is equivalent to 2,000 joules per seconds. Remember, power, we can use power for, or we can use triangle for power. Power is equivalent to work divided by the time. Okay? You already know how to use the triangle. If you need help, you know where to find me. Goodbye, everyone.